Problem number 6. Finally onto some differentiation. So we're going to differentiate these three different functions. This one is updated. Instead of an x here, it should be a z. Not a big deal, but just to make sure. So now we're going to differentiate these functions. So first, a is f of x equals the natural log of sine of 4x. So looking at this, it looks like I'm going to need chain rule because I have log there. So my inside function is sine of x. My outside function is log. So by the chain rule, derivative of log of something is 1 over that thing. So 1 over sine of 4x times the derivative of sine of 4x, which is equal to 4 cosine 4x divided by sine of 4x. And there was actually technically another chain rule done there with 4x as an inside function. But I would be more than comfortable with you just saying derivative of sine of 4x is 4 cosine 4x at this point in the course. So that's our final answer there. Next is b. G of x equals e to the x divided by x log x. So this isn't the most fun looking derivative, but it's not going to be particularly difficult, just annoying. So we're going to have to use quotient rule together with product rule. So in the numerator, the derivative of e to the x is just e to the x. So the numerator isn't where we're too annoyed just yet. Denominator is x log x. So d dx of x log x by the product rule is equal to first times the derivative of the second plus derivative of the first times the second. But this isn't too unreasonably hard to evaluate. X times the derivative of log x, that's 1 over x. So x times 1 over x is 1. Plus derivative of x is 1, so plus natural log of x. And then we just smush these together using quotient rule. So g prime of x is equal to low d high, so x log x times d dx e to the x minus high d low e to the x times the derivative of x log x all divided by x log x all squared. So that's the quotient rule in action. And then finally this is x e to the x log x, because we already showed derivative of e to the x was that, minus e to the x 1 plus log x, because we already did that derivative as well. And that's all divided by x log x all squared. And looking at this, there's nothing that I can simplify because I don't have e to the x on every term, or I have e to the x on every term on top but not on bottom, and that's the only thing they share. The best I could simplify would be to say this is e to the x log x minus 1 plus natural log of x. over x log of x squared. And that's g prime of x. Next is h of z. H of z is equal to sine of log of z. So we want to take a derivative. And again, this looks like it's got some chain rule to it. So h prime of z is going to be, first I'm taking a derivative of e to the something. So by chain rule, we're going to have the derivative of e to the something is e to that something. So sine log z, and then times the derivative of the inside function. So d dz sine of log of z. So, okay. Now we need to do another chain rule because we have sine of log x, log z. So this is e to the sine log z times, and then the derivative of sine is cosine. And I leave the inside function alone by chain rule. Times d dz of log z. So that needed two applications of chain rule. The more practiced you get, the more quickly you can hammer these out. So this is e to the sine log z times cosine natural log of z. And the derivative of log of z is 1 over z. So I can just divide everything by z, because that's the same thing as multiplying by 1 over z. And that is the end of that derivative. And also is the end of number 6.